Okay, everybody. Welcome back to 2.4, where we're going to continue our applications of linear equations. All right, so it's really 2.3 and 2.4 go together. They're just applying linear equations to real world situations. What you're going to see is they all share a common process. They really are all a lot alike. What we're going to work on now is hashtag investment probs, investment problems. So you all know when you invest money, you earn interest. That's what this is all about. And we're going to use what's called the simple interest formula. And that formula is principal times rate times time is equal to the interest earned, okay? Principal times rate times time. All right, so look at these steps. They should look familiar. We want to identify a variable. We want to make a table. We want to make an equation, and we're going to solve and check for reasonableness, just like before. Okay. Now, in this problem, $60,000 was invested, some at 2% and some at 3%. In 1 year, $1,600 was earned in interest. How much was invested at each rate? So look, I made this table and I have the two different investments and calling them investment 1 and investment 2. Just like before, the other equations that we were given, principal times rate times time equals interest. So we're going to fill out the principal, the rate, and the time. And how do we get the last column? All the time, every time? We multiply across, okay? All right. Now, what is the variable? What do we not know? We look at the question, and it says, how much was invested at each rate? So we don't know the principal. The principal is the original amount that was invested. I don't know how much was invested here, and I don't know how much was invested here. So we know that we can assign a variable to the principal, right? That's what we're trying to find. So I can call this X, and I call this X. What we don't have here is any proof that, that the investments were the same amount though. So we might have to adjust this box in a little bit, but let's see what we can fill out here. Do we know the rates of the investment? I believe we do. I believe it was told 2% was the rate at one of the investments and 3% was the rate at the other investment. Now, remember, when we're working with percents, we're going to want to write their equivalent in a decimal. So if you remember, 2% as a decimal would be 0.02, and 3% as a decimal would be 0.03. Okay? And is the time given to us in the problem? I believe it is. I believe it says in 1 year, this much interest was earned, okay? Now, so for the time, we can fill out 1 and 1. Look, this table is really coming along. Let's see if we can fix the P column using the information that $60,000 was invested. Okay, so $60,000 was invested, and let's say X dollars of that $60,000 was invested to investment 1. Well, not necessarily is it the exact same amount invested in investment 2, but we know that if $60,000 was invested together and we take away X dollars out of that money to put investment 1, how much does that leave for investment 2? So we started with $60,000, and we're gonna take out or take away the X dollars that were invested in investment one. What does take away mean? We're gonna do 60,000 minus X for that amount. Think about it. X of the $60,000 was invested to investment one. We take that away, and then we're left with 60,000 minus X. Another way to look at it is, if you were to add these two investments together, all the money invested here and all the money invested here, it would add up to 60,000. So what is X plus 60,000 minus X? Well, the X's would cancel and you'd be left with your $60,000 of total investment. I know it's tricky. With practice, we get better, okay? That's the hardest part of these types of problems, but you do it a few times and you got it, I promise you. Now, how do we get this column all the time, every time? Multiply. So I have X times 0.02 times 1. Well, the 1's not going to play a factor really. I think the best way to write that would be 0.02x. And again, to get this column, I have 60,000 minus X times 0.03 times 1. I think the best way to write that, because it doesn't matter the order in with which we multiply them, would be 0.03 times 60,000 minus X. All right. Now, how do we set up the equation? Look, let's look at our little rubric. We identified a variable. We made a table. We're making great progress. Now we need to make an equation. Well, we know that the total interest earned from both investment was $1,600. And if we look at our word bank, where does total mean? Total means mathematically to add. This box here, this 0.02x, represents the interest earned from my first investment. And this box here that says 0.03 times 60,000 minus X, well, that represents the interest earned from investment number 2. Now the total between the both of them is going to add up to 1,600. So that's how we're going to make our equation. I'm going to add this box plus this box and equal it to 1,600 and solve. So 0.02x plus 0.03 times 60,000 minus X equals the total interest earned of 1,600. Okay, so we go back to our steps of solving, which is we're going to distribute first, right? So 0.02x plus 60,000 times 0.03 is 1,800 minus 0.03x equals 1,600. Next in my steps is to combine like terms. So I'm going to combine the 0.02x and the negative 0.03x, and I get negative 0.01x plus 1,800 equals 1,600. And now I'm going to subtract 1,800 from both sides, and I get negative 0.01x is equal to negative 200. And it looks like our x might be negative, but really, last step is to divide by negative 0.001. And And this is pretty neat. Negative 200 divided by negative 0.001. Well, that equals $20,000. So the amount of money invested in investment one is $20,000. $20,000. And then to find out how much money is invested in investment two, I'm going to take the $60,000 and subtract the $20,000, and investment two equals $40,000. Right? Is it reasonable? Absolutely. What would be unreasonable in this situation? Well, if you have $60,000 to invest, anything less than zero, you can't invest a negative amount of money, or anything bigger than 60,000 wouldn't make sense. Because together they have to add up to 60,000, and they do. What a great problem. Thank you so much. Let's try one of these on our own.